Alright, I'm gonna get started right now. Problem 1 is y equals x times sine of x, then dy dx is equal to, this is just a product rule. So to get y prime, you just have to take the first part's derivative and then the second part's derivative, and so this is how you do it. So you take the x prime times sine of x plus the derivative of sine of x times x. The derivative of x is just 1. So you get 1 plus sine of x, and then the derivative of sine of x is cosine of x multiplied by x. So the final answer would then be sine of x plus x cosine of x. And the only option that matches this is option B. So number 1, the answer to this is B. Question 2 states, let the function f be the function given by f of x is equal to 300x minus x cubed. On which of the following intervals is the function f increasing? We know a function is increasing if its first derivative is greater than 0. That would imply the slopes are positive, and hence the function must be increasing. Because of that, we have to solve for f prime of x. The f prime of x is equal to, we're just going to do basic product rule, not product, but power rule. So there's a 1 here, we just bring that down, that gives us 300, and we subtract 1 from the exponent, that gives us 3x to the power of 0. That's just 300 minus 3x squared. After this, you're going to have to figure out critical points. So then set the 300 minus 3x squared equal to 0. This would then mean if I divide by 3 all across, I get 100 minus x squared needs to equal 0. And because this is a difference of squares, you can say this is x minus 10 and x plus 10 is equal to 0. Solving for this gives us x could either equal 10 or negative 10. And I like to draw a number line to figure out where they are either increasing or decreasing. So these are our critical points, negative 10 and positive 10. And anything, so we're going to check this region, this region, this region, so here, here, and here. If at any of these possible regions the function's either positive or negative, that would imply the function's increasing, or decreasing. So to the left of negative 10, if I were to plug in, let's say, a like negative 20 in here, again, this is no calculator portion of the exam, so if I were to plug in negative 20, this number would clearly be positive. So the x in here would make it a positive because it's squared, and then multiplied by a negative 3 would make this clearly a bigger number than 300, because we figured out negative 10 is the least number you can have to get a 0. So this would, any number to the left of it would create a negative value in the function. That would mean the f is decreasing here. So it's decreasing to the left of negative 10, and here, let's say I plug in 0. Plugging in 0 gives us this value to be positive. So here this is increasing, which is what we want. And then let's just go ahead and check after 10. After 10, same thing as if I plug in 20, it behaves the same as it does below negative 10. Same thing, this value will be greater than 300, leaving us with a negative. So f is going to be decreasing here as well. So the only part that this is going to be increasing on is from negative 10 to 10. So the answer must be B. What is the integral of secant of x, tan of x? And I think the best way to do this is just to memorize the integral, right? The integral of secant of x, tan x, you just need to know this fact that the derivative of secant, if I take the derivative of secant of x, that is equal to secant of x plus tan of x plus so this is the integral. So because of that, we know for a fact that if the integral basically asks what's the antiderivative. So whose derivatives is secant x tan x? Well, the derivative of secant of x gives me secant x tan x, and again we have the plus c for a constant because that just goes to 0. So number 3 is going to be A. Alright, number 1 says if f of x is equal to 7x minus 3 plus ln of x, then f prime of 1. We first figure out the derivative of f of x is equal to, here we just need to do the power rule to get that 7x minus 3, is the derivative of that is going to be equal to 7. The derivative of ln of x is equal to 1 over x. Now it's just simply plugging in 1. 7 plus a 1 over 1 is 7 plus 1, which is 8. So the answer to number 4 is E. Alright, number 5 says the graph of the function f is shown above. Which of the following statements is false? The limit as x approaches 2 of f of x exists as we go to 2 from the left and the right. The limit approaches 2, so that's true, so that's not false. The limit as x approaches 3 exists as we go to 3, same deal. From the left and the right hand limit exists at 3, so that's also true. Limit as we go to 4, from the left it approaches 2, from the right it approaches 4, so this is not true. So I'm liking C. Letter D says limit as x approaches 5, so that's over here. From the left and the right, that also exists, so it's at that point at 6, so that exists, so that's not correct. The function f is continuous at x equals 3, that's true. The limit exists and the function's defined there, so that's not, that's also true. So the only thing that's not true is C. So number 5, the answer is C. Okay, number 6 says a particle moves along the x-axis. The velocity of the particle at time t is 6t minus t squared. What is the total distance traveled by the particle from time t equals 0 to time t equals 3? Remember that to figure out total distance, you have to take the integral of speed with respect to time from a certain time t equals a to t equals b. We're going to do the same thing here, but we're going from time t equals 0 to t equals 3. And the speed is always defined as the absolute value of the velocity. So this would be equal to the integral of the absolute value of 6t minus t squared dt. And as a matter of fact, this function is always positive from 0 to 3, so there's no need to put an absolute value sign. You can just say this is 0 to 3 of 6t minus t squared of dt, and this would be equal to, you can just split up the integral and do the power rule with the first part equaling 6t, t1 plus 1 is 2, so it's just basic power rule, 2 over 2 minus t cubed over 3, and we're taking the integral from 0 to 3, so this would then equal 3t squared minus t cubed over 3 from 0 to 3. And if we just plug in our numbers, 3 squared is 9, 9 times 3 is 27, minus 3 cubed is 9 over 3. Oops, 3 cubed is 27 over 3 is 9. And then, as you can see, if I plug in a 0 into any of these, that gives me a 0, so I don't really have to subtract anything. So this is just minus 0 in the end. That equals 18. So the answer to this is going to be option D. That's the total distance the object, the particle, travels. Alright, number 7 says if y equals x cubed minus cosine of x to the power of 5, then y prime is equal to, for this one, you just have to do power rule. If I let this is my inner function, so I first have to take the derivative with respect to my inner function, which would give us 5x cubed minus cosine of x to the power of 4, and then because of chain rule, I now have to take the derivative of the inner portion, which is 3x squared. The derivative of cosine is negative sine of x, so the answer to this is going to be equal to 5 times x cubed minus cosine of x to the power of 4 times 3x squared plus sine of x. And the only one that correctly represents this is letter E for number 7. Alright, number 8 says a tank contains 50 liters of oil at time t equals 4. Oil is being pumped into the tank at a rate R of t, where R of t is measured in liters per hour and t is measured in hours. Selected values of R of t are given in the table above. Using a right Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at time t equals 15 hours? The most important point is they want a right Riemann sum with 3 subintervals. So I always start at the right if it's a right Riemann sum, and at the left if it's a left. So here we pick this as my endpoint, so I'm going to take 5.6 that it lasted. So the rate, so to figure out the amount of liters of oil that's in the tank, you're going to take R of t multiplied by t. As you can see, this is liters per hour multiplied by hours would give you liters as your unit. So taking the area under the graph would give you the answer to the question. So when I'm doing the right Riemann sum, I'm going to look at the right hand point, which is 5.6, and then I'm going to multiply it by, and I'm going to approximate that this is the value that it stayed on for 3 hours, because that's what it elapsed here, between 15 and 12. 3 plus, from 12 to 7, that's 5 hours, so we're going to assume that this was the rate, liters per hour, for 5 hours. Plus 6.2 times 3. So this is a approximation for the amount of the change in the number of liters. So when I solve for this, this gives me 5.6 times 3 is 6 times 3 is 18. 5 times 15 plus 1 is 16.8. So this is 16.8 plus 5.9 times 5. 5 nines are 5 times 9 is 45. 5 times 25 plus 4, 29.5. 6.2 times 3. 3 times 2 is 6. 6 times 2 is 18, so that's 18.6. And this gives us 3.6, 16.8 plus 29.5 plus 18.6. All of that added up gives us 8 plus 5 plus, so that gives us 1. So it's 8 plus 5. So this gives us 64.9 liters. Now, don't be tempted to choose this answer, right? The reason is because, don't pick A. One of the most important reasons is because they're asking us, what is the number of liters that's in the tank, right? This is only the change. This tells us how much did it change by from the time t equals 4 to 15. So this is the amount of approximate change in the number of liters. So this is the amount that it gained. So the crucial information here is the tank contains 50 liters at time t equals 4. So you're going to have to take 50 plus this amount, and that's the final answer, which is 114.9 liters. This is the final answer because now you took the initial starting amount plus the change to get your final answer, and that's C. Alright, number 9 states that let the function f be the function defined above. For what value of f is f continuous at x equals 2? For it to be continuous, both the limit and the point that it is there needs to match. So because this is most of our function except for at 2, if we look at this, 2x plus 1 multiplied by x minus 2 over x minus 2. These cancel, leaving us with 2x plus 1. That tells us that at x equals 2, because that's where this is undefined, there is a hole in the graph. And if we think about a graph, our point would be something like this at x equals 2. So this is at x equals 2. This is probably not crossing the origin, but you kind of get the idea. Because of this, you're going to have to make sure that the point, you have to figure out what point this would be technically if it were going through it. 2 times 2. I'm just plugging in the x value of x equals 2 into this equation. Plus 1 is 4 times 2 is 5. 2 times 2 is 4 plus 1 is 5. So the y value of this would be 5. So again, if we look at the equation, this would be 1. This is exactly how the line would look like, the function. And this is at 5. So to make sure that it is continuous right here, we have to make sure that the point equals the limit. The limit equals 5. So the point needs to also equal 5. So hence k must be equal to 5, which is E. All right, number 10 says, what is the area of the region in the first quadrant bounded by the graph of y equals e to the x over 2 and the line x equals 2? So if you think about this, we're basically just taking the integral of y from 0 to 2, because that's the first quadrant. We're in the first quadrant, that's why I'm starting at 0. So because of this, dx, this just equals the integral of e to the x over 2 dx from 0 to 2. I'm going to set my u to equal x over 2 du. Dx is then equal to 1/2 x. That implies then that du is equal to x over 2 dx, and dx is equal to, if I just multiply by 2 on both sides, 2 du over x. Oops, sorry, there shouldn't have been an x here at all. Should have just been a 1/2. Same thing here. So then that would have told you that dx is equal to 2 du. Given this fact, we can just replace our quantities, e to the u, and then dx we said was 2 du, so that's 2 du, and we can just take the 2 out of the integral. And I'm just going to ignore the limits for now, and I'm just going to solve this. This just equals 2e to the x over 2. And then we can just take the limits from 0 to 2. That equals 2 times e to the 1 minus e to the 0. That just equals 2e minus 2. Again, if you're actually on the on the FRQs, do not do what I did here, right? I omitted the u's and I just kind of like set them equal to each other. This is not equal, this is not proper. If you were doing it properly, you would solve for u, which is x over 2, so you would have 0 here and 1 here. But I just didn't worry about that because this is just an MCQ. So the answer here regardless is 2e minus 2, which is A. Alright, number 11 says, let f be the function defined by f of x is equal to square root of the absolute value of x minus 2 for all x, which the following statement is true. So for this one, the first one says a is continuous but not differentiable at x equals 2. B, f is differentiable at x equals 2. F is not continuous at x equals 2. Well, let's go ahead and get rid of the options that are pretty easy to determine. The first one is x is not continuous at x equals 2. If you think about it, as the numbers get close to 2 here, if the absolute value of x minus 2, right? If I plug in like 3, for example, 3 is, or like 2.9. 2.9 minus 2, I get like 0.1. And similarly, square root of 0.1. Similarly, if I do something very close, if I do something like 3 or a number pretty close to 2, you can see that the values equal the actual limit there. So the limit and the point is defined at 2. If you think about the graph, it's actually like a cusp here at x equals 2. So this is continuous, so it can't be c. Limit as x approaches 2 of f of x is not equal to 0. Well, we just figured out, I mean, look, if you plug in 2 into this function, that equals 0. So this is defined there. So not only does the limit, as you get closer and closer to 2, the limit goes to 0, the function is also equal to 0 at the point. So it's not c or d. E says x equals 2 is a vertical asymptote. That's not true. We got a point, so that's not a vertical asymptote. So now we're left with a and b. Now, to figure out if it's differentiable, basically the slopes at the point have to be defined, right? If you think about f of x is equal to square root of 2 minus x for x is less than 2, and square root of x minus 2 for x is greater than or equal to 2. This is the reason. The reason this is because if it's greater than or equal to 2, we can just plug it in, right, to the original x minus 2. But if it's less than 2, we're going to have to take the negative of this. And so this is basically just saying the square root of the negative of x minus 2. That's all I did. So I just negated this. So we still plug in the values that are less than 2. We just have to negate this. The negated version would read 2 minus x. Now, similarly, if we just went across and did f prime of x, that would equal negative 1/2, 2 minus x to the power of negative 1/2 for x's that are less than 2, and 1/2 times x minus 2 to the power of negative 1/2 for x's that are greater than 2. Now, clearly, because this is kind of our f prime of x function, if you think about it, at 2, the slopes clearly don't match, right? I mean, what I'm trying to say is clearly this is the slopes do match. They're 0, but the slopes before and after don't match, like immediately before and after, because they're defined by 2 different functions, which would imply that the function is not differentiable. And this would also let you know that it's a cusp and that you cannot differentiate it, right? And again, you can think of it, right? You figure out the limit as you get really close with the limit definition, but on the other side, it's just totally different. So it's just not possible to differentiate right there. So the answer is that this is continuous, but it's just not differentiable. So the answer to this is going to be A. All right, number 12 says, using the substitution u equals square root of x, the integral of from 1 to 4 of e to the square root of x over square root of x is equal to which of the following? First thing, I'm just going to replace the variables in here with a u, right? But before, actually, if we say that u is equal to the square root of x, right, the u is equal to 1 over 2 square root of x dx. This would imply that 2 du is equal to dx over the square root of x. So I just took the derivative of u. So now that we figured that out, we can go ahead and start replacing stuff. So if I multiply 2 du square root of x is equal to dx. So into our initial equation, e, now we just replace square root of x with u over u, and the dx is now 2 du square root of x, right? Which we again called as u, which would mean then that these parts would cancel, so that would just leave us with 2 du. Now is the final part, which is figuring out the limits, the upper and the lower limit. Because we figured u is equal to the square root of x, our upper u would be equal to the square root of, because it was 4 here, we just plug in 4 and that gives us a 2 as the top. Similarly, the denominator is 1, so we just plug in u is equal to the square root of 1 is 1. The bottom is going to be 1. So here is our definite integral rewritten with u, which is c. All right, number 13. The function f is defined by f of x is equal to 2 for x is less than 3, x minus 1 for x is greater than 3. What is the value of the integral of 1 to 5 of f of x dx? For this function, I just like to split up the integral. So this would be equal to, because we define anything less than 3 is 2, so I'm going to do anything from 1 to 3 is the function 2 dx, and anything from 3 to 5 is going to be x minus 1 dx. So the first part is going to be equal to 2x, because that's the integral of 2 from 1 to 3, plus the integral of the first part is x squared over 2 minus x, and these are both from 3 to 5. So this first part is going to be 3 times 2 is 6, 6 minus 2. I'm just plugging in 3, so I'm plugging in 2 times 3 is 6, and then 2 times 1 is just 2. That's our first part. Plus, and then now we plug in the 5 into these, 5 squared over 2 minus 5, minus 3 squared over 2 plus 3. I'm just, I already subtracted, I already distributed the x's. So the final answer comes out to be D, which is 10. Alright, 14 says, if f of x is equal to the square root of x squared minus 4 and g of x is equal to 3x minus 2, then the derivative of f of g of x at x equals 3 is, this is just chain rule, this would be equal to f prime of g of x multiplied by g prime of x. And we just have to plug in at f of g of x at, so if we take f of g of 3 derivative, that would equal f prime at g of 3 multiplied by g prime of 3. So this would equal f prime of x is equal to, let's just go ahead and do that to the side. F prime of x is, this is just, if I take the derivative with power rule, that gives me 1/2 x squared minus 4 multiplied by the inner function's derivative. Subtract 1 on the top, and then multiply by the inner function's derivative, which is just 2x. Right, so the f prime of x is equal to this. So if I just go ahead and plug in 3 into this, and then we're going to have to plug that into here. So let's go ahead and plug in 3. 3 times 3 is 9. And 9 minus 2 is 6. 9 minus 2 is 7, sorry. So this is 7. So I just plugged in a 3 here. Multiplied by g prime of 3. And if we just solve for g prime is just 3. So this would be 3 here. And going on, if I plug in a 7 into my f prime function, this is x squared. The function would be equal to f prime of x. This is f prime of x, by the way. Sorry for the very sloppy work. And you have x squared minus 4 to the power of, you have 2x over the x squared minus 4 times 2. So this is the function. Now you just plug in a 7 into this. So you just have 7, and then these 2's can disappear, so you can just say this is 7 over 7 over radical 7 squared is 49. 49 minus 4 is just 45 times 3 is equal to 7 over radical. The radical 45 is equal to 3 radical 5 multiplied by 3. So that just gives you 7 over radical 5. So that's a, to summarize, I did the chain rule, which is f of g of x prime would be f prime g of x times g prime of x. And then we just plugged in a 3 into this, which we first solved by plugging in. 3 times 3 is 9. 9 minus 2 is 7. And then g prime of 3 we figured would always equal 3, so we just set that equal to 3. And then f prime of 7, we figured out that f prime is equal to this expression right here. And we plugged in a 7 into this, and we got radical 47 over radical 45. So this is equal to 7 over radical 45 multiplied by 3 is equal to 7 over 3 times radical 5 times 3. So that's equal to 7 over radical 5. So the answer to that is A. All right, number 15 states the graph of a differentiable function f is shown above. If h of x is equal to the integral of 0 to x of f of t dt, which of the following is true? Well, if we think about h of 6, right, if I just plug in 6, that's the integral of 0 to 6 of f of t dt. So if I go from 0 to 6, this would be my value, the area under this function, which would be some negative value, right? So we know that h of 6 is some negative value. All right. Now, if we take h prime of x, according to this fundamental theorem of calculus, if I take the derivative of the integral, I just get f of x here, okay? So now if I plug in 6 into h of x, h prime of x, so if I plug in h prime of 6, that should be equal to f of 6, which is equal to 0. So h prime of 6 is equal to 0, okay? And h double prime of x would be, well, we had h prime of x is equal to f of x, so we just take it again, we have f prime of x. So if we take h double prime at 6, then that's equal to the f prime at 6, which is equal to, well, we can see that's a positive slope right there. So h double prime at 6 would be some positive quantity. This would tell you that h of 6 is a least, and then h prime of 6 is 0, and then h double prime of 6 is a positive. So this would be the correct ranking of the elements. So there you go. So 15 is going to be A. All right, 16 states a particle moves along the x-axis with its position at time t given by x of t is equal to t minus a, t minus b, where a and b are constants and a is not equal to b. For which of the following values of t is the particle at rest? What I like to do is first understand what it means to be at rest, which is when v of t is equal to 0. So we have to take the derivative of x of t, x prime of t would be equal to v of t, right? So the velocity is 0, which means the object is at rest. With that in mind, what I think would be easiest to do with the derivative is just first distributing this. So I'm going to first distribute the t's. That gives me t squared minus bt minus at plus ab. this here is x of t. I'm gonna pick a different marker. This one's being weird. Okay, so now this, because this is equal to x of t is equal to bt. Now if I take the derivative of this, that gives me 2t minus b minus a, and this part just goes away. And again, like we said, this is the velocity. So if I take, and if I set x prime of t equal to 0, that tells me where the object is at rest. 2t is equal to b plus a, t is equal to b plus a over 2. So this is the time the particle is at rest. So 16 is going to be b. Alright, 17 says the figure above shows the graph of f. If f of x is equal to the integral of 2 to x of g of t dt, which of the following could be the graph of y equals g of x? Well, if you do the fundamental theorem of calculus, f prime of x would be equal to g of x, right? So this would be equal to y. What is f prime of x equal to? Well, if you look at the graph, there's always a constant and positive slope, right? So it cannot be c, d, or e, because all of these represent a non-constant g of x value. Because f prime of x is positive and and it's constant, 17 has to be a, because this is a constant value and it's positive. All right, number 18 says the limit as h approaches 0 for the ln of 8,4 plus h minus ln of 4 divided by h is. For this one, you just have to think about the limit definition of a slope. All they're doing is they're taking delta y over delta x, but the change in y is very minute. So the ln of 4 plus h, so I'm just adding a very tiny bit, minus ln of 4 divided by 4. These h's and 4's are terrible, sorry. So here you have 4 plus h minus ln of 4 over h plus 4 plus h, 4 plus h minus 4. So this is delta x at the bottom. And this tells us ln of 4 plus h minus ln of 4 over h. Now, here, all this is telling us is we're figuring out slope of ln of x at x equals 0. So, if we just take the derivative of ln of x, that gives us 1 over x. And if we solve, we are figuring out the slope at 4, my bad. This 0 is just, we're adding a minute bit to this. So this is the slope at x equals 4. So because the derivative of ln of x is 1 over x, we just have to plug in a 4 in here. So that tells us the slope at x equals 4 is equal to 1 over 4. So the answer is, to 18 is B. Alright, number 19 says the function f is defined by f of x is equal to x over x plus 2. At what point x comma y on the graph of x have the property to the line tangent to f at x, y has slope 1/2. Okay, for this one, you're going to have to figure out where f prime of x is equal to 1/2, because that's where the tangent line, the slopes, the derivative basically tells us the tangent line slopes. So to take the derivative of this, you have to take the derivative of the top, which is 1 times x plus 2, minus the derivative of the bottom, which is 1 times the numerator divided by the denominator squared. This is the derivative. This is f prime of x. So simplify, this is x plus 2 minus x over x plus 2 squared is equal to f prime of x. And these x's can cancel, and we just have a 2 on the top. Now, given this, you just have to now figure out where this equals 1/2. So just set 2 over, now you just have to set 2 over x plus 2 squared is equal to 1/2. This tells you that 4 is equal to x plus 2 squared, and 2 is then equal to x plus 2, the absolute value of x plus 2, because look, if you take the square root here, the square root of x squared, x plus 1, x plus 2 squared would give you the absolute value of x plus 2, and that would tell you x plus 2 needs to equal 2, or x plus 2 needs to equal -2, and then solving for this, x could either equal 0 or x could either equal -4. So these are the points where the tangent line has a slope at 1/2, so boom, boom. So the two places where 0 and -4, so it has to be C, because none of these encompass the slope. So yeah, the other point in the coordinate is they just plugged in the actual value into the function to figure out the y coordinate, but in this case you don't have to do that. They already tell us. We just have to figure out where the slope had to equal that. Alright, 20. Let the function f of x equal 2x plus 1 to the power of 3, and let g be the inverse of the function f. Given that f of 0 is 1, what is the value of g prime of 1? You need to realize if g is the inverse of f, taking the inverse of a function's the derivative of an inverse function is equal to 1 over f prime of g of x. This is the entire thing. So you're taking, if you take the derivative of the inverse of a function, that's equal to 1 over f prime of g of x. I think you should memorize this. It comes in handy. So if I'm plugging in g prime of 1, that would be equal to 1 over f prime of g of 1. And then g of 1 would be equal to f prime of g of 1. Now, what do you think would be the value of g of 1? They tell us g is the inverse of f. So if we plug in 1 into this function, so like again, because this is the inverse, so we just have to swap the x's and the y's of this. So if I swap that to say x equals 2x plus 1 cubed, 2x plus y plus 1 cubed. Now here all I'm doing is I'm just swapping the things, and this would be equal to g of x. The reason that is because they tell us the inverse. Now if we plug in a 1 as the x, if I plug in a 1 here, 1 would be equal to 2y plus 1 cubed. Taking the cube root of both sides, this gives us 1 is equal to 2y plus 1. Subtract, it gives us 0 is equal to 2y, y is equal to 0. So if I plug in 1, then my g of x is equal to 0, right? Okay, so then what we do is we just say, what is f prime of 0? Then we're going to have to derive this. So that's f of x equal to 2x plus 1 cubed. And taking the f prime of x, this is just chain rule and power rule. 3 comes down, you have 2x plus 1 squared. Multiply by the derivative of the inside, which is 2. You get 6 2x plus 1 squared. And then you just have to plug in a 0 into this. So you have 6 times 2 times 0 plus 1 squared all over 1. Sorry for the terrible formatting. I shall move this down. So this is 6 times 2 times 0 plus 1 squared is equal to 1 over 2 times 0 is 0, 0 plus 1 is 1. 6 times 1 squared is just 1/6. So the answer to this is 1/6. The main important point in solving this equation was realizing this formula right here, this formula. I think I would personally memorize this. Let f be the function defined by f of x is equal to ln of x over x. What is the absolute maximum value of f? To figure that out, we're going to figure out the critical points of f of x, which we do by taking the derivative of f of x, which again we do by quotient rule. We take the numerator's derivative, which is 1 over x, which is 1 over x multiplied by denominator, minus the denominator's derivative, which is 1 multiplied by numerator over denominator squared. And this gives us 1 minus ln of x over x squared. And because we're figuring out critical points, we have to set this equal to 0 to see where the critical points align. 1 minus ln of x is equal to 0, and ln of x is equal to 1, which would imply x is equal to e. So our critical point occurs at x equals e. If we draw a number line and center it at e, to figure out if this is a absolute maximum or a local maximum, to figure that out, we just have to check to see if f prime of x is f prime of x is either positive or negative. So if I plug in a value, let's say 1 here, you can see that if I plug in 1, bottom is going to be 1. ln of 1 is definitely less than 1, which would mean the values here are going to be positive. So f prime of x is going to be greater than 0, which would imply the function is increasing. Now, after e, if we have, for example, 2e or something, the values here would be greater than 1, leading us to have a negative value here, which would mean f prime of x is less than 0, indicating that f of x is decreasing. So if we think about the behavior of f of x would have behaved something like going up to e and then coming down. This would mean that there was a absolute maximum value at x equals e. Now the question's asking us what is the absolute maximum. Now we figured out that this is where the maximum lies at x equals e. We just have to plug in e into f of x. So if I plug in e into ln of e over e, that gives me 1 over e. So the absolute maximum is 1 over e. So this is both the relative maximum and the absolute maximum of the function. So the answer is B to the function, number 22. All right. 23 states, if P of t is the size of a population at time t, which of the following differential equation describes linear growth in the size of the population? Linear growth. If there is linear growth in P of t, which would mean P of t looks something like this in a graph, right? It's constant, the slope is always constant. Then if you took dp dt, that must be a constant value, right? Because the value in the line, horizontal tangent lines must always have the same value, so it cannot be B, C, D, or E. It only has to be A because that's the only constant here. So 23 is A. All right, 24 states, let g be the function given by g of x is equal to x squared times e to the kx, where k is a constant. For what value of k does g have a critical point at x equals 2/3? For this, you just have to think about what does a critical point mean? Well, that means when g prime of x is equal to 0. So if I take g prime of x, that is equal to x squared times e to the kx multiplied by k, because of chain rule, plus, I'm doing the product rule here, times e to the kx multiplied by 2x. That's a derivative of this, of x squared. So if I factor out e to the kx, I get e to the kx is multiplied by x squared k plus 2x. And then this would then equal 0. So if I solve for 0, right, but at g prime of 2/3, because they say that's where the critical point lies, then I can just plug in a 2/3 everywhere I like, which would be k 2/3, wherever the x's are, 2/3 squared times k plus 2 times 2/3. So again, this needs to equal 0 because that's our critical point, and then this is equal to e to the 2/3. K times 2/3 squared is 4/9 k plus 4/3 is equal to 0. And then we can just cancel this out by dividing by that on both sides, and we know that 4/9 k plus 4/3 needs to equal 0. Solving for k needs to equal -3. So this is what k needs to equal to give us a critical point at x equals 2/3. All right, 25 states of the following. Which of the following is a solution to the differential equation dy dx is equal to 2 sine of x with the initial condition y of pi is equal to 1? Well, the initial condition is y of pi equals 1, so we got to make sure all of these have at least match the pi of 1. So what I do is I plug the pi into the equation, see if it equals 1. So cosine of pi is -1. -1 times 2 is -2 plus 3 is 1. So let's try this. Pi, cosine of pi is -1 times 2 is -2, -1 minus 1 is -3, so it can't be b because it doesn't follow the initial condition. C does the same thing. That gives us 5. This gives us +2 plus 1. Nope. This gives us negative. This gives us +2 minus 1. Okay, so now we're left with A and D. I mean, right off the bat, just checking the initial condition allowed us to cancel out 3 of the options. So now we just have to make sure if I take dy dx of part of option A, dy dx, that's equal to 2. The derivative cosine is negative sine of x. So that clearly doesn't match. So our answer is E. So if you wanted to check, you could always take the derivative of E, which is -2. The derivative cosine is a negative sine of x, and that does give us 2 sine of x. That matches. So 25 is E. 26 says let g be a function with the first derivative given by g prime of x is equal to the integral of 0 from 0 to x of e to the -t squared. Which of the following must be true on the interval from x is 0 to x is 2? So, if you think about this, right, g prime of x, as we go from 0 to 2, if I plug in any value into this, right, I always get a positive number, right? That would tell us that the area is positive because all values in here are going to be positive numbers. So if I take the area under the graph, that's also going to be positive. That tells us g prime of x is always greater than 0. What does that mean for g? G has to be increasing. So it cannot be c, d, or e because they say it's decreasing. Now, what about whether it's concave up or down? If I take the double derivative, that tells us, if I take the derivative of this again, then it is negative e to the negative x squared, right? Same thing. If I plug in any number from 0 to 2, this value is always positive. So this is always greater than 0, which would again imply g is concave up. Because g double prime of x is always greater than 0, this implies concave up. This implies it's increasing. So it's A. 27 states that if x plus 2y times dy dx is equal to 2x minus y, what is the value of d squared y, the second derivative of y, at 0.30? Okay, so if we solve for dy dx, that's equal to 2x minus y over x plus 2y. And if I solve for the second derivative, that's equal to, if we do the quotient rule, you get x plus 2y multiplied by 2 minus dy dx minus 2x minus y multiplied by 1 plus 2 dy dx over all over x plus 2y squared. Now if I plug in 3, 0 for this, right, which would imply I could easily just replace these at 3, 0, because I'm trying to figure this out at 3, right, at x equals 3. Or I'm trying to figure this out at 3, 0. So if I do that, I can plug in wherever the x's are 3 and the y's with 0. Same thing, 2 minus. Now for dy dx, we do the same thing. We just plug in 3 for x here minus 0 over 3 plus 0. So this gives us 6 over 3, which is 2. So we know that dy dx is 2 at 3 comma 0. So we just plug in 2 wherever this is equal to minus, and then we get 2 minus 2, which is 0. So this part just goes away, and we just have now this, which is negative 3 times 2 is 6. 6 minus 0 is just 6. Multiplied by 1 plus 2 times 2 is 4 plus 1 is 5 over 3 squared. This is 3, right? 3 squared. It should be squared here. Alright, so now this equals negative 30 over 9 or negative 10 over 3. So the answer would be A. All we did was take the second derivative, plug in values that we need. Okay, 28, the last problem in the no calculator portion. For time t is greater than or equal to 0, the position of a particle moving along the x-axis is given by x of t is equal to sine of t minus cosine of t. What is the acceleration of the particle at the point where the velocity is first equal to 0? The velocity of the particle is equal to the derivative of its position with respect to time, which is, if I take the derivative of sine, that's cosine of t. Derivative negative cosine is positive sine of t. If I figure out where this is equal to 0 first, cosine of t plus sine of t is equal to 0. I'll take this off. You know that this happens, cosine of t equals negative sine of t. If you think about the unit circle, right, out here at 3 pi over 4, 45-degree angle right here, the x's and the y's are opposite in sign. So technically here, if you want to think of it like this, sine of t is opposite of cosine of t at t equals 3 pi over 4, right? Because the sine would be radical 2 over 2. Cosine would be negative radical 2 over 2. So this condition is satisfied when t equals 3 pi over 4. Okay, so now that we figured that out, we have to figure out acceleration, which would be the double derivative of time, of position with respect to time. So taking the derivative once more, that gives us negative sine of t plus cosine of t, and that's and if I plug in 3 pi over 4, because that's what the question's asking, what's the acceleration at that point when it's first equal to 0, and if you plug in 3 pi over 4 into this, you get positive radical 2 over 2, and if you multiply by negative, you get negative radical 2 over 2 plus, well, the cosine of 3 pi over 4 here is negative radical 2 over 2. So this then, because they're the same denominator, you can just add them, and that gives you negative radical 2. So that's the answer. It's A. And then we'll get started on the calculator portion of the 2012 MCQ. All right, we're back. So number 76 in the 2012 calculator portion of the MCQ. The graph of the function f is shown of in the figure above, for which of the following values of x is f prime of x positive and increasing. So what I like to do is just check every option. At point A, the slope is pointing downward, which would mean, so this would imply then the slope is negative, so cannot be A. For B, it's not differentiable. At C, it's positive. At D, it's negative. And at E, it's positive. So now we narrowed it down to C and E. Now all I have to do is check whether it's increasing. So if you check E, the slopes are actually going downwards. It's concave down. But at E, the slopes are getting more and more steeper. So E is the correct answer. 76 would be E. Let f be a function that's continuous on the open on the closed interval from 2 to 4 with f of 2 equals 10 and f of 4 equals 20, which of the following is guaranteed by the intermediate value theorem. Now, the intermediate value theorem requires that we have a closed interval, we have a continuous function, which is correct, and which satisfies the requirement, so we can use this. Now, what the intermediate value theorem states is because it's continuous, the function from 2 to 4 must have passed through every value. So must have gone through each point from, as we go from 10 to 20, right? It must have went through all the points between 10 to 20, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, including the decimal points too. So A says f of x equals 13 has at least one solution in the open interval from 2 to 4. That's correct. It must have at least gone through it once. It could have gone through it twice. It could have gone through it 1,000 times, but at least has to go through it once. So like A. B says f of 3 equals 15. You don't know if that's necessarily true, but yeah, it does have to go through it, but you don't know if it goes through it at 3. C says f attains a maximum on the open interval from 2 to 4. You have no information about that. Nothing about slope. F prime of x, as soon as I read f prime, I don't even know if it's differentiable, so I just don't even read it. Same thing, E, we don't know if it's differentiable, so the answer to 77 has to be A. Number 78. The graph of y equals e to the tan of x minus 2 crosses the x-axis at one point in the interval 0 to 1. What is the slope of the graph at this point? Well, we first have to determine where it crosses it. So we set this equation equal to 0 to see where it crosses the x-axis. Tan of x minus 2. 2 is equal to e to the tan of x. Take the ln of both sides. You get ln of 2 is equal to tan of x. And then x is equal to tan inverse of ln of 2. So this then equals, this is the point where it crosses the slope, so then you just have to go on your calculator. This is the point where it crosses the x-axis, so we just go on the calculator, type in e to the derivative of e to the tan of x minus 2, and figure out my derivative at inverse of ln of 2. That's how you do it. When you do that, the calculator must tell you where the point crosses. It tells you the derivative at this point. So when I plug this in, this tells me the answer is D. 79 states a particle moves along the x-axis. The velocity of the particle at time t is given by v of t, and the acceleration of the particle at time t is given by a of t. Which of the following gives the average velocity of the particle from time t equals 0 to time t equals 8? To figure out average of a function, of any function, you just take the area under the graph divided by the duration of whatever you're going from. So here we just take 0 to 8 of v of t. We're figuring out average velocity. So we take the integral from 0 to 8. This gives us area under the curve multiplied by 1 over 8 minus 0. So that the correct answer for that is 79. If they ask for what's the average speed of the object, then you would pick C, because then they're doing the absolute value of that. We should make it correct. So for here, this would be B. Alright, 80 sets a graph of f prime. The derivative of the function f is shown above. Which of the following statements must be true? Because this is the f prime's graph, right? Keep that a note. Number 1 says f has a relative minimum at x equals -3. So 1, 2, 3. So this is the point we're looking at. F prime of x, because this is negative, there's a negative sign. F, which would mean f is decreasing before x equals -3 and increasing after x equals -3, which would imply f must have behaved something like going down and then going back up. This must mean there's a relative minimum. That's correct. So 1 is good. 2 says the graph of x has a point of inflection at x equals -2. So if we think about x equals -2, that's over here. That's right there. If the point of inflection changes sign, right, which means the slope on this graph, if you have f prime of x changing, f double prime of x changing signs, that would imply it is an point of inflection. Here at x equals -2, the slopes are positive of f prime of x, and then they continue to be positive, which indicates that this is not really a point of inflection, so it can't be 2. 3 says the graph of f is concave down for x equals 0 to from 0 to 4. That's true. The slopes are always negative, right? Which would imply this is concave down. So the ones that are true are 1 and 3, which is E. Water is pumped into a tank at a rate of R of t is equal 30 times 1 minus e to the negative 0.16 t gallons per minute, where t is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes? So for this one, you're basically going to have to say water in tank is equal to initial amount plus amount pumped in 20 minutes. So the water in tank is equal to initial. We're starting with an initial of 800 gallons plus the amount that's pumped is the integral. All write this over here. This is equal to 800 plus the amount that's pumped in 20 minutes is the integral of r of t from 0 to 20 of r of t dt. Plugging this into your calculator, you should get 1.220 gallons. That's D. Alright, number 82. If f prime of x is equal to this, then f has a local maximum at x equals. Well, to figure this out, you just have to think about where is f prime of x greater than equal to 0 before a critical point and after, and it's less than 0 after. And so if you think about it, at 0.35 we're positive before the critical point and negative afterwards, which is what we want, which would imply that this is the behavior and there's a local maximum. At 1.324, it's decreasing before, so it's going down and then going up afterward. That's a local minimum, so this is 0.35. Alright, 83 says the graph above gives the velocity v in feet per second of a car for time is greater than or equal to 0 and less than or equal to 8, where t is the time in seconds of the following, which of the following best estimates the distance traveled by the car from time t equals 0 until the car comes to a complete stop. For this one, you just have to take the area under the curve because it's feet per second. When you multiply that by second, feet per second multiplied by second, it gives you total distance traveled, which is what the dimensions you need. So to figure out the area under the curve, you can just best approximate this by drawing a line. So let me do that real quick. If you draw a line from here to here and just figure out the area under the curve by just using a triangle, and I think that's best approximation because here it over approximates and here it under approximates, and the symmetry might be pretty good. So what I'm going to do is find the area here, which is 50 times 8 times 1/2, and that gives us the answer as 200, which is pretty close to 210. So you can pick D. There's multiple ways to do this. You could have split this up into rectangles and done it. It's up to you. Alright, this question says for x between negative 1.5 and 1.5, let f be a function with the first derivative given by this. Which of the following are all the intervals on which the graph of f is concave down? Now, because this is f prime of x, merely just looking at the slope shall tell us whether this is concave up or down. So, to note, if you think about it, as we go from negative 1.5, which is somewhere out here, the slopes are always negative until we reach here, which is where it's 0. So we know from negative 1.5 to 1, the function, the normal function, is concave down because f prime, double prime of x is less than 0 because the slopes are negative. From negative 1 to 0, the slopes are positive, which would imply f double prime of x is greater than 0, and hence it's concave up. So that's not included. And as we go from 0 to positive 1x, the slopes are all negative. Again, that means it's concave down. So we go from 0 to 1. That's concave down as well. And after 1, these are all positive slopes, indicating that f double prime of x is greater than 0. This would let us know that the only option that matches concave down would be D for 84. The graph of f prime, the derivative of f is shown in the figure above. The function f has a local maximum at x equals, well, because f prime is given to us, we just have to look at critical points like this and this. Before x equals 1, 2, 3, this is x equals negative 3, because before negative 3 we had a negative f prime, which would mean the slope, the function was going down, and afterward the f prime is positive, which would mean normal function was going up. So this is f of x. This is how it behaved. This would indicate a local minimum. So that's not it. What about out here? Here the function is positive before and negative after, which would indicate going up and coming down, which would be correct. And so answer to 85 is C, because that's where the function rises before x equals 1 and decreases after x equals 1, which would imply a relative maximum or a local maximum. We're going to do 86 now. If the function f prime of x is greater than 0 for all real numbers x and the integral from 4 to 7 of f of t dt is equal to 0, which of the following could be a table of values for the function f? What you got to realize is that the function is always increasing. So if we look at the table of values, the function's always increasing. That's good. Here we are also increasing. That's good. Here we are increasing. And for some reason, we just decreased, which cannot be possible because we always have to be increasing. Here we always stayed the same, which is not possible. They literally tell us it always has to be greater than 0. For E, we're always increasing, so that's good. All right. Oh, sorry. That is good. So now we eliminated C and B. The next part is to look at the area, because we're going from 4 to 7 of f of t dt, and the area is equal to 0. If you think about the y values here, because we're always increasing, and we start at -4, and we go to -3 and go to 0, this should imply that our y values were always less than 0. And if we take the area of the function, the area must also be negative, which cannot be possible, right? Our area must equal 0. If you look at B here, we went from -4 to 2, and then we go to 5. That kind of tells us that possibly we had a negative area here, and then this 5 allowed us to counteract that negative area with a positive area and possibly get to 0. So it could be B. And E, same thing. We went always positive. This would mean there's always a positive area. There's nothing to counteract that positive area, right? So it cannot be E. The only correct answer is B for 86. 87, the graph of f prime, the graph of f double prime, the second derivative of f is shown from -2 to 4. What are all the intervals on which the graph of the function f is concave down? Well, because they gave us f double prime directly, we just have to literally look at the data points and see where it's negative. As you can see, as we go from x equals -2 to -1, it's always 0, so -2 to -1 is concave down. From 1 to 3 is concave down. So the only thing that satisfies that is E. So 87 is E. 88, a person whose height is 6 feet is walking from the base of a streetlight along a straight path at a rate of 4 feet per second. If the height of the streetlight is 15, what is the rate at which the person's shadow is lengthening? So if you think about this, here is 15, here is 6, here is the shadow's length with his S, and the distance between the walking person and the street lamp is going to be, streetlight is X. The most crucial part is setting up the equation in this related rates question, which would be the congruence of the triangles with this and the bigger triangle, which is this. To the first triangle, if I take this side over x plus s, which is this big triangle here, that must be, the ratio must be equal to the little triangle over s, so here. Solving for this, you get that 15, s is equal to 6s plus 6, 15s is equal to 6x plus 6s, and that 9s is equal to 6s, so s is equal to 2/3 x. And the next part they tell us is that ds dt, the rate at which the rate at which the person walks, or the rate at which the shadow lengthens, is equal to 2/3 that of dx dt. Right, dx dt is the rate at which the person walks. So if you just plug that in, they tell us that's 4. That would be equal to 8/3 feet per second, which is equal to 2.66 repeating. So the answer to this is B. Alright, a particle moves along a line so that its acceleration for time t is greater than or equal to 0 is given by a of t, which is equal to t plus 3 over square root of t cubed plus 1. If a particle's velocity at time t equals 0 is 5, what is the velocity of the particle at t equals 3? All you have to do is say the velocity at 3 is equal to the velocity at 0 plus the integral from 0 to 3 of a of t dt. This should explain the overall velocity, its ending velocity at time t equals 0. If you just plug this into your calculator, you get 5 plus 6.710, that equals 11.710, or E is the final answer to this question. So number 90 says let f be a function such that the integral from 6 to 12 of f of 2x dx is equal to 10, which of the following must be true. So for this, we're first going to set t is equal to 2x, and if I replace the elements of the integral here, we have the integral of f of t dx from upper and lower limit, which we can find by taking so I basically just plugged in my x values to get my upper and lower limits in terms of t's. Now to replace dx, we're going to have to do this. Given this fact, we can now replace our dx with dt over 2. And this should now equal now remember that we only replaced the values in here, which would mean this should still equal 10. So multiplying by 2 on both sides, we should get 12, 24, dt is equal to 20. So the answer to this question is going to be B. This question says let f be a polynomial with values of f prime of x at selected values x given in the table above, which of the following must be true for the x from -2 to 6. They tell us it's a polynomial function, which means it's differentiable, which should remind you of the mean value theorem. The question says the graph of f is concave up. As you can see here, right, from -2 to 0, you know that there must have been some negative f double prime, which literally indicates it cannot always be concave up because they're switching stuff. The slopes seem to switch. B says the graph of f has at least 2 points of inflection. That's possibly true because look, if we think about the mean value theorem here, there must have been some negative f prime, but here because we went f double prime, but because we went from 1 to 4, we must have increased, which means there must have been some positive slope involved. So there must have been a positive f double prime. This indicates that between 3 to 4, there must have been a point of inflection. Similarly here, we increase, and here we decrease. This indicates that there must have been some slope of f prime of x graph where the slope was negative to establish this decrease. This indicates, again, there's 2 points of inflections because the sign must have changed. So I like B. And C says f is decreasing. That's not necessarily true. This could have technically dipped all the way to -50 and then came back up in the intervals. You don't know that. F has no critical points. Again, you don't know. It could have went to 0. If it's at least 2 relative extremas. Again, we're not sure about critical points. So the answer to 91 is B. Let R be the region in the first quadrant bounded below by the graph of y equals x squared and above by the graph of y equals square root of x. R is the base of the solid whose cross-section perpendicular to the x-axis are squares. What is the volume of the solid? If you think about the graph, you have y equals x squared, which is like this, and y equals square root of x. Now we're basically making cross sections out of this portion that's in between, that is in between the two curves. So what we need to think about is what's the point of intersection. The intersection that they both have is at x equals 1. At x equals 1, they both meet up at point y equals 1. So all we have to do to figure out the volume of the created, you just have to take the upper curve minus the lower curve. That gives you the height. So you just take the upper curve, which is square root of x, minus x squared, and you have to square it because you're making square cross sections. So that gives you the area of each individual square, and you're going to multiply that by dx, an infinitely small, thin extension from your little square, and then you're going from 0 to 1 in your x. This will provide the volume for the entire shape, and when you plug this into your calculator, the final answer you obtain shall be 1.129, which is A. Alright, we just finally completed both the calculator and no calculator portion of the AP Calculus AB 2012 MCQ. If you guys have any questions, leave them in the comments below. But that's about it. Good luck on your exams that are upcoming.